basic information about firewall. Basically, if you are a manager or a project manager or a program manager, and if you want to understand what is firewall without going into in-depth technical nitty-gritty, so this will help you to understand, and to prepare for even for interview questions. So let's start with the session. So what is firewall? So basically, a firewall is a device which is used to protect your corporate network or your LAN. So protect from what? Protect from an untrusted network. So what is an untrusted network? The outside world or the internet. So basically, that is what is the firewall used for. So how does the firewall protect a corporate network? It protects the corporate network by filtering the incoming or the outgoing connection. So what do you mean by filtering the incoming and outgoing connection? Filtering means you will allow only what is needed, or you will filter out what is not needed. Okay. So this is how the firewall gives the basic protection to your corporate network. So on what basis? What is the criteria to filter the incoming or outgoing connection? So basically, the firewall will perform the lookup at the rules to permit or deny a connection from for outgoing as well as incoming connection. Now, what does that rule consist of? What do you mean by a rule? Basically, the rule will consist of the source. What are the source IPs that are allowed to communicate, and on what port, source port, and again to what destination IP they can talk to outside their corporate network, and on what port. So this is the basic rules. Okay, source IP, destination IP, source port, and destination port. So based on these four tuples, you create a rule. So how does the rule look like? You can see here, on the screen. There will be a description to the rule. Like for example, you want to allow a telnet for a particular machine from your corporate network. So what source protocol it will be? It will be a TCP. Suppose if you mention here IP, what will happen? If the moment you mention IP means you allow the entire the IP suite. IP suite is what? It's basically a group of protocols. So under the IP suite, everything comes like TCP, UDP, H323, the voice protocols, and ICMP. All the protocols will come under the IP. So when the moment you say IP, it means the port is any. It covers everything. So if you want to be more specific, if you want to put more specific information inside the rule, then you will have to mention the source protocol. The source protocol is TCP, and the source IP, and then on what port you will be initiating the connection. What is the source port? Normally the source port, if you will see any firewall rule, you will see the source port as any port. The reason why we keep it as any, because if you are trying to initiate a connection from a user desktop, okay, so it will initiate on any port, ranging from 40,000 to 50,000 port, any port. This is what we call ephemeral port. You will not know on which port it will initiate the connection. So that's why you put as any in the source port. Then again, as you said, here we are going to telnet a particular machine. So that machine who you are going to telnet will be listening on that port number 23, TCP port number 23. So you are going to allow a destination protocol TCP, destination IP, and the destination port. And this is the syslogs. If you want a log to be generated for this rule, okay, you will have to enable the syslog. Of course, on the firewall, you will have to configure a syslog IP where these logs will be pushed. So then again, you will have to configure a machine or a virtual machine, and you will have to assign a hard disk, to accept those logs or to store those logs. So which can be used later on for forensics or for troubleshooting as well. So this is how the firewall rule looks like. So TCP source port protocol can be TCP, or it can be an IP, or it can be UDP, or any other protocol like H3.323 for a voice protocol, or any like any protocol for Microsoft Azure if you want to connect to any application. Okay. And destination protocol, same. It can be an IP, or most likely it will be a TCP protocol. Okay. So destination port can be AT443 or RDP 3389 or any destination port which works on TCP, UDP, or any like H323. So this is how the firewall rule looks like. So here this is what I have mentioned. If you mention an IP in source and destination protocol field, it signifies that all the protocol TCP, UDP under the IP suite are open along with all the ports. Now comes a very important question on firewall. What is a stateful firewall? So if you want to understand what is a stateful firewall, you should understand the TCP, the states of TCP. Okay. So whenever a TCP initiates a connection, it will initiate with a three-way handshake. So it's like, when you meet a person, you say hello. And then that person has to respond with a smile or with a hello. So that means now you are ready to talk to that person. Okay. Or that person is willing to talk to you. Similarly in TCP, when a TCP initiates a connection, it will start with a three-way handshake. If that three-way handshake is completed, only then the data transfer will happen. Okay. So that means if the three-way handshake is completed, that means the session is established and data can be sent over between the two machines. So what are the three-way handshakes? If you don't know, you can refer to my shorts. Okay, but anyways, I will let you know now itself. The sender will send a SYN packet. It's like a hello to the server. The server which receives the SYN packet will respond with a SYN, with the acknowledgement to that SYN packet, and it will also send a SYN, a synchronization packet, to the sender. The sender will receive this SYN packet and acknowledgement, and then it will send an ACK packet to the received SYN. So it's like SYN packet, then SYN ACK, and then ACK. This completes the three-way handshake. Now the sender is ready to send the data and recipient is ready to receive the data. Okay. So as the communication proceeds, the sender will send a SYN packet. Sender will send the data along with the SYN packet. Now the sender will expect an acknowledgement to the SYN which it has sent. Okay. So if it receives an acknowledgement, that means the data is successfully delivered to the recipient. So when that data is sent by the sender along with the SYN will have a sequence number, for example X. The recipient will respond back to that SYN with an acknowledgement, and the sequence number of that acknowledgement will be X plus 1. So the sender will come to know okay, that this acknowledgement is for that particular SYN, for a SYN with a sequence number X. Okay. Similarly, the server side or the recipient side will also send a SYN. Okay, if it is responding with the data, okay, then it will also send a SYN because it also expects an acknowledgement for the sent data. So it will send a SYN along with the data, and that sequence number of that SYN will be Y, to which the sender will respond with an acknowledgement Y plus 1, Y plus acknowledgement with the sequence number Y plus 1. So the sender will maintain a table, a TCP table, a state table of SYN sequence number and acknowledgement sequence number. Okay, and recipient will also maintain a separate table of its own SYN sequence number and acknowledgement sequence number. So each recipient as well as sender can track their whatever the data has been sent, and if they have received the acknowledgement. If suppose they have not received the acknowledgement for any particular SYN, then that same data will be sent. That is what the TCP does, right? Error recovery. So this way, the stateful firewall will make use of this SYN and acknowledgement sequence number. Okay. And it will come to know the incoming connection is a response to which outgoing connection. Okay, so so in a stateful firewall, you will only find the rules going from inside to outside. There will be no rule for outside to inside. Basically, any person from outside, if he is trying to send data directly, that connection will be rejected. Only those connection, those incoming connection will be allowed for which there is an outgoing connection. Okay, and that outgoing connection is tracked by the firewall using the state table. Okay, it will come to know, okay, this incoming connection has an acknowledgement of x plus 1, okay, which was the acknowledgement to a SYN which was sent with a sequence number of x, so it will allow that connection. Okay, so that way it maintains the state, and you don't have to put the rules for incoming and outgoing. It will be only for outgoing connection. Correct. So this is what I have explained in the slide, that a user is initiating a connection from source IP 10.10.1 to outside IP 2.2.2 on destination port 80. The response from 2.2 to 2.2.2 will automatically be permitted. However, if 2.2.2.2 tries to connect the 10.10.1 exclusively, means if he sends an independent connection, then that connection will be denied, as there was no outgoing connection in the state table. So by default, all the incoming independent connections are denied. So here let's understand through animation what is the stateful and stateless firewall. So the user is sending a data. Okay. Now because there is an outgoing connection, the response to this outgoing connection will be automatically permitted. But if the outside device tries to send an independent data or independent connection to an incoming to an inside device, it will be denied. That the connection will be denied. But in stateless firewall, you will have to put the rule for outgoing as well as for incoming. Okay, because the firewall is not going to maintain the state table. So even though there is a outgoing rule which permits the outgoing connection, but because it cannot track the state of the TCP, it will not allow the incoming connection if there is no rule for the incoming connection. So there will be two rules for each connection. Okay, so basically nowadays you will find most of the firewalls are stateful firewalls. Stateful firewalls are more costly, and stateless firewall are cheaper as compared to stateful firewalls. There are many vendors of who provides firewall. Like nowadays, the Palo Alto is the most famous firewall vendor. Okay, most of the organizations are using Palo Alto, but there are other vendors also like Checkpoint and Cisco ASA, and they also provide the firewalls. Now, what are the security zones in the firewall? So when you talk about firewall, you need to understand what are the security zones. So every firewall will have basic two interfaces. One is for corporate network and the other is for outside network, internet network. Okay. So that is how the firewall works, right? The firewall has to protect your corporate network from the outside world. So there will be two interfaces. So basically, interface will represent a subnet. Two interfaces means two subnets. So one will be an inside interface or a trusted network, or other will be outside interface or untrusted network. Now you assign a security level to the trusted and the untrusted. So normally the most trusted network is assigned a security level of 100. So your corporate network or your LAN will be assigned a security level of 100. Okay, it is the most secure network, or that network needs more security. Then again, in the corporate environment, you will also see one more interface for hosting the server. Now, why do we need a DMZ server? So DMZ or a server form. You don't want that any outside person to enter into your corporate network. Now suppose if you are hosting your web server from your LAN, then any person who wants to reach out to that web service will have to connect it from the outside world to your corporate network, correct? Because your server is lying in the corporate network. Suppose if he is a hacker, or if he is sending a malware, then your entire network will be infected. Okay, so that's why you carve a different subnet for for servers, which we call as a demilitarized zone or server farm. So if anything happens wrong here, if the server farm is infected, then that malware or virus will not spread into your corporate network. Okay, so that's why you will see three interfaces. One will be for corporate network or trusted network, the other will be for internet or untrusted network, and the third interface will be for DMZ server. Although if you want to create more zones, you can create it. Okay, if your firewall allows for more interfaces, you can do it as well. You can name it, and accordingly you can host any kind of service. But normally you will see these three network on the corporate firewalls. So now from this diagram, it is very clear that always the traffic from a higher security zone is allowed to a lower security zone, but not the reverse way. Okay, so if at all in the reverse way, if you want to allow, then you will have to give a limited access. For example, the users on the internet is trying to access the DMZ server, so they will be trying to access the URL. Okay, for example, https www.example.com. So the web service example.com is hosted on in this server, so they will reach out to this server on port number 80. So they have a limited access. Okay, so that is how the configuration is done on the firewall. The basic, when I say incoming connection, means the connection going towards the device or coming inside the network, or outgoing connection means the connection going away from the device or outside the network. Now, what are the different types of firewalls? Firewalls can be network firewall. Network means in the OSI layer, network layer is a layer 3 layer. Okay, is a layer 3, and IP address works on layer 3. So a firewall which filters the packet based on the IP address only is called a layer 3 firewall. And then comes a layer 4 firewall, the packet which can filter the packets using the IP address and the TCP port combination. It is called a layer 4 firewall. And then layer 7 firewall is the application layer firewall. At application layer, the protocols that you will see is HTTP or HTTPS. Okay, so that firewall has a capability to do the deep packet inspection. We call it as a DPI, deep packet inspection, and it can see what are the contents of the TCP or of the HTTP header. If it finds any malicious content in the TCP header, then it will block the connection. So it is a more advanced firewall, application layer firewall. Now, where does the firewall fit in the network? Normally, firewall is placed at a perimeter between the corporate network and internet, but it can also be placed between two organization networks. Suppose one organization is taking over another organization. So initially, for temporarily, you can put a firewall between the two networks, and before the complete transition happens, you will simply allow few connections from this network to that network. Okay. And also it can be placed in a ODC. What is an ODC? ODC is offshore development center. For example, there is an organization, any specific organization A, and it has a client, big client called D, and the client wants that any user who is working for the corporate D should enter into a specific area, okay, which they call as offshore development center. So though it will be in the same building of the corporate A, but it will have separate access. The ODC will have a separate access, and the infrastructure of ODC will be different from the rest of the corporate network. There will be a firewall, okay, between the ODC and the corporate network, so that nobody can download anything from your corporate network into the ODC or send any data from inside to corporate network. So that is like basically the the client who will, the corporate D or the client of the corporate A will decide whether they want to have a separate ODC or not, and you have to comply with the customer. So that is how the firewall fits in the network. So basically firewall will sit between two subnets which needs to be isolated from each other, and only limited communication is allowed. Okay. So that was all about the basics of the firewall. Thank you.